Hello, my name's Steve Wisby and I'm going to present to you today about our unmanned ground vehicle called Zeus, which we have designed for the EOD, CBRNE search and surveillance requirements. So originally we designed the robot for EOD to deal with conventional disposal and improvised explosive device disposal. But we were always aware from the beginning that there would be a requirement for robots in the CBRN world. So we took in the CBRN design characteristics required as well. There are 12 points I'd like to discuss about the Zeus robot, and these are broken down on the screen now. So first I'd like to start with the modular concept. So Zeus is a modular design. It has discrete modules which come together to configure the robot. And in the center image you can see a 3-section arm with flippers. This is our most capable version of Zeus. The long 3-section arm has good reach, it's got lots of dexterity, and the flippers has substantially improved the obstacle clearance and stability. But if you needed a more simple robot that was lighter, you could have, for example, the one on the right-hand image, which only has a 2-section arm and no flippers, or we could even go right down to a 1-section arm with no flippers, making a very light, quick-to-deploy, simple robot. But let's talk about how this modular concept works. So it all starts with this base chassis, and everything I'm now going to show you can be done by an operator. It doesn't need to be done by a technician. The wheels simply slide on with the tracks, and they bolt on and hold like that. The communications chamber that has all the radios and all the communication system with the controller is just held in that single module there, and it's held on with 4 bolts, and it just bolts on, comes off very easily, and it's even possible for operators to change it if they wanted to operate on a completely different frequency band. Very much the same with the battery compartment. So the battery compartment goes on the left side and simply bolts on with 4 bolts. The flippers, again, they simply have 3 bolts and they just simply bolt onto each track drive wheel. The arm is on a quick release. It just drops down and locks into place. And the same with the gripper. It comes off very easily, goes on very easily, and then just locks into place. The robot can operate either by radio or with a tether, 200-meter tether, and these simply bolt to the bottom of the arm. So if we're on antennas or tether, these just simply bolt to the bottom of the arm. There are 5 cameras in total: a front camera, a rear camera, a pan-tilt camera, a camera looking through the middle of the gripper, and a 5th camera which mounts onto the arm, which is normally mounted looking at where the disruptor is aiming. So both the robot and the controller are both modular. Everything I've just shown you there can be done by an operator. The robot can be configured to different configurations for different missions. It's also very easy to ship. So these modules, the robot can actually be broken down into its discrete modules, which allows it to be easily shipped in small storage compartments or broken down between, for example, 2 people in a backpack. It's also extremely easy to repair. So if a module breaks, such as the gripper or maybe the communication system, an operator can simply swap that module out in the field. So on to point number 2, transportation and deployment. We really wanted to keep it under the 55 kilo area because this allows 2 people to lift it. So it can be quickly deployed from small vehicles with just a 2-man lift. This is the kind of terrain that it can cope with, so it easily can cope with stairs at 45 degrees, obstacles of 40 centimeters, ditches of 60 centimeters, and sideway lateral slopes of 35 degrees. Maximum speed is 3 kilometers, and the track design is rubber, but it's got an aramid or Kevlar reinforcement. Why is that important? Well, many robots, when they get into very hot weather, the rubber tracks become soft and expand and can easily jump off. But the aramid reinforcing within the rubber track stops the track from stretching and jumping off. This is a basic image of its reach and height capability. Can reach up to about 2 meters, can reach about 1.3, 1.4 meters to the side and 1 meters from the front. And this is the strength capability map. So maximum reach is about maximum lift is about 15 kilos close to the robot, and with the arm fully extended, maximum lift is about 5 kilos. Talking about cameras now, there are 5 cameras in total. As I said, 1 at the front, 1 at the back, a pan tilt, a camera that looks through the middle of the gripper so you can see what the gripper's doing, and a 5th camera which can be mounted onto the side of the disruptor. It's also possible to view up to 4 cameras on the screen at the same time, so you've got this multiplexing option available as well. The fixed focus cameras have a digital zoom and the pan tilt has an optical zoom. The cameras all operate in low light, so as you go from a bright area to a darker area, the camera will still function. But if it goes into a very low light area, you have white lights which you can switch on and off. And in addition to that, there's also an infrared light capability. So talking about communications, so the robot is actually paired to the controller. The beauty of pairing the controller to the robot is it means you can operate multiple robots side by side without the fear of one robot being accidentally controlled by the other controller. But it's also possible for operators to swap controllers around with robots. They're not fixed from the factory. It's a very simple task to swap controllers around between robots if an operator wanted to do that. When working on radio, there's two types of radio. There's a data transceiver. The data for that is encrypted to AES-128. And that's the radio, that's the data that's actually controlling the robot. It has a variable power level, so up to 3 kilowatts, up to 3 watts. And the standard frequency is 458 megahertz, but we can do different frequencies for different customers. And it's also possible to operate on multiple channels. And again, as I mentioned before, the beauty of that is you can have robots operating side by side. The video transmitter is a COF-DM. Its power is also variable for up to 1 watt. Standard frequency is there on the screen, but again, special frequencies are available if a customer requires it. And again, the video also has multiple channels, which allows multiple robots to operate side by side. Typically, radios operate up to 500 meters, and you can actually change the frequency range to a completely different range by changing the modular communications chamber. When working on tether, this is a fiber optic cable. It's about 200 meters long. We do have an optional 1,000 meter fiber optic cable, but that's only a single use. Talking about communication still, so the robot has 2 USB ports. These are useful if operator wants to mount a sensor, like a chemical detector, so we can mount up to 2. In fact, we can actually mount more than 2 by using a hub. And that can communicate with a wide range of different protocols. So whatever you want to communicate with. Different sensors have different methods of communicating. Some are RS-232, some are RS-422, some are 485, some are actually USB. And all these methods of communication can still be connected to the robot. Talking about power now, so typical mission endurance about between 2 and 4 hours. So if you're doing a typical mission, you're normally getting up to 4 hours with no problems. If you're doing lots of stair climbing, lots of driving, lots of skid steering, then the mission duration may fall back slightly. The robot uses a standard 2590 lithium-ion battery. The robot itself has 2 batteries and the controller has 1 battery. So the robot batteries, these are 2 just mounted very simply externally. When these batteries go in, it's all watertight, very quick to change, less than about 1 minute. And the same with the controller. The controller only has 1 battery, but again, very quick to change. It's a standard charger for the robot and the controller, operates on 110 volts and 240 volts. The status of the batteries is displayed on the controller. So on the left, you can see the OCU, and in this example, it's 54%, and the robot is at 91%. And this is telling you at a glance the status of the battery on both the controller and the robot. But if you click on either of these icons, you can actually get more information about the robot. So in this screenshot here, we've taken the information for the robot batteries. Now there's 2 robot batteries. One is, as you can see, on 87%, and the other one is on 65%. And there's some additional information we can get from the battery here. For example, the unique serial number, the number of times it's been recharged, its chemistry, and the date of manufacturer. This is all very useful stuff if you need to manage your battery inventory. There are power supplies on the robot, so we've got 2 12-volt supplies in the arm, and 1 12-volt supply on the chassis and a 24-volt supply on the chassis. So if you need to mount equipment that needs an external power supply, there is a power supply on the robot. Talking about disruptors now, so we have a universal disruptor holder that can hold all the disruptors from ABP, Chemring, Richmond, CTS, which is Canadian Technology Systems, and PropArms. We recommend only the mounting of recoilless disruptors. We can mount and fire recoiling disruptors, such as pig stick and hot rod, but this is by special arrangement. Typically, disruptors are close water shots between 50 and 100 millimeters, but we can also fire standoff shots with projectiles, and we have an innovative twin camera aiming system that's extremely accurate at firing standoff projectile disruptors. So this is typically how the disruptor is mounted. In the image on the left, you can see the disruptor is mounted on the side of the gripper. And if you can see there, you can spin the gripper around 180 degrees and still use the gripper. Then when you need the disruptor, you turn by 180 and now you have your disruptor. Or alternatively, you might want to dispense with the gripper and mount the disruptor directly onto the end of the arm, which is shown in the image on the right. Typically, this is how it's done. There's the claw on the end of the arm. You have a universal mount goes on there. The coloured sleeves change depending on which disruptor you want to mount. In this case, this is an ABL 2000. You can also mount an external RF firing system. So in this example, that's a Chemring. This is a laser aiming system that allows you to aim water shot disruptors to about 50 to 100 millimeters in front of the disruptor. And a camera is mounted on the disruptor as well, allowing you to see where the disruptor is aiming. Typically, aiming disruptors using lasers where the laser comes together at 50 to 100 millimeters just in front. You can use lasers to do standoff. So in the bottom image, you can see up to 25 meters. It's actually very difficult to aim. Even when not mounted on a robot, it's very difficult to aim a standoff disruptor using lasers at 25 meters, which is why we developed a camera aiming system, which is much more accurate. And we'll talk about that in just a minute. So this is actually our standoff aiming system. We mount firing these kind of disruptors is very specialist. So you need to make sure you've got the requirements to fire. You actually need to fire standoff disruptors, but we do that by mounting two cameras. We don't mount one camera when we're firing standoff disruptors. We actually mount two cameras side by side, and this allows us to aim in two axes and achieve a very high level of accuracy. This is the interface for aiming the standoff disruptors, and you can see in one image we've got one camera, in the other image we've got the other camera, and we just align in the left and the right planes to get the accuracy. Typically, firing disruptors, the standard system supplied with Zeus is the FOG system. It's a German system. It's approved by BAM. It's a fully certified and authorized firing system. It's mounted down on the chassis. We have one firing circuit as standard, but you can have up to 4 firing circuits. And this firing system will work regardless of whether the robot is on a radio control or on a tether. The transmitter for the FOG firing system simply plugs into a USB port on the controller. It is also possible to mount third-party radio firing systems. So in these images here, you can see an Chemring Breach, MC Breach, and a Marine Air Systems. And all these, if you already have these in service, we make holders for all these types of firing systems, and these can be mounted on the robot, and you can use your in-service system. It's important to remember, though, that these are radio-controlled firing systems, therefore they won't work on tether. In terms of CBRN, so typically on a CBRN robot, we take the gripper off, we mount these two plates on the chassis and the arm, and that allows us to mount a range of different types of disruptors. Different types of sensors. The sensors are held with a rubber strap. They're not sensor specific, so a very wide range of different shaped sensors can be held. It's a universal mounting system, and the robot is able to accept a wide range of communication protocols. All different sensors communicate different ways, but it doesn't really matter what communication protocol that sensor uses. We can accept that into the robot and transmit that back to the operator. And as I mentioned before, if any sensor needed an external power supply, we have 12-volt and 24-volt power supplies on the robot. When working in a CBRN environment, we use a chemical agent resisting or CARC paint for the painted parts of the robot, and the other parts are made from stainless steel and titanium, which is extremely corrosion resistant. I've already explained about the modular design, and the modular design allows itself very well to break down the robot into its individual discrete modules, which allows it to be thoroughly decontaminated. You can imagine a robot's a very complicated device with lots of crevices where contamination could get caught up, but by being able to disassemble all the individual modules, it's possible to give it a thorough cleaning. It's also worth bearing in mind at this point that as the modules are disassembled from the robot, they are themselves watertight. And of course, the robot is itself waterproof anyway. Obviously, we want it to operate in rain and humid conditions, but it's also waterproof so it can be washed down, especially in a chem-bio decontamination situation. The robot can hold up to 30 kilos. It is resistant to temperature, water and dust resistance. It's been tested for vibration and shock and for EMC. These are the range of temperatures it can operate and be stored on, and this is tested to BSEN 60068. These tests have been done by an independent test house. Water and dust resistance, you can see it here at an independent test house being tested for both water and dust resistance. The robot is IP65 and the controller is IP54. The reason we make it waterproof is obviously because we want it to be capable of operating in the rain, but also waterproof for being washed down and for chem bio decontamination. Robot's also been independently tested for vibration and shock. Vibration and shock are induced by two methods. Basically, when it's stored in the vehicle and being taken to task, there's a certain level of vibration and shock induced by that, and also vibration and shock induced by the UGV actually during use. There are various methods and standards for testing for vibration induced by transport, for vehicle, railway, ship and aircraft. And these are the testing. This is the testing that we've done. We've tested to 60068. This is the standard that we work to. We don't test to the American MIL standards or the STANAGs. We can test to those standards, but that's only if a contract specifically requires it. Vibration induced by the robot itself is tested by us empirically. There is no international standard to test that to. These are the EMC directives that we test the robot to. So EMC, this is the electrical noise a robot gives out to make sure it doesn't interfere with other equipment, and also the fact that it's immune to electrical noise being given out by other equipment. So in this case, we test to an EU directive to make sure it's suitable. Training, so each robot comes with 5 days training, and that's included in the price of the system. There's a number of safety features I'd like to talk about. So the robot and the controller both have an emergency stop in case of an accident, and it's also possible to send an emergency stop to the robot from the controller. So if the robot's on task and you see some incident where you want to shut that robot down fully and not allow it to operate anymore, you can send an emergency stop to the robot. We've also carried out failure modes effect analysis on the safety factors and a system safety analysis. And this is all about making sure that every possible scenario has been considered and that the operators of the system are completely safe. And finally, the last thing I'd like to talk about is full life support. So we're able to remotely connect into the robot through the internet. We can do online software updates and also a significant amount of fault diagnosis. Standard warranty is 12 months with the robot. It's a return to base warranty. Each robot is delivered with an international transport case system. So it's just simply a case of getting that robot back into that transport case. We'll bring it back to the UK, do the repair and send it back. And although it might seem counterintuitive to bring the robot back to the UK to repair, it's actually easier, because if we were to send an engineer out to site, he would then get there, analyse the fault, then may need spares. We'll have to wait for those to come out. Whereas by bringing it back to the UK, we can get it back here quickly, fix it and get it straight back to you. We have a configuration policy, so we have a detailed build of exactly how the robot's delivered. And this is important because 5 years down the line, when you need some maintenance, a module may no longer be available. Maybe the current design, it may have been superseded, but we have a 10-year support policy, and we will make sure that all modules on all parts of the robot can be supported up to 10 years. And finally, end-of-life disposal. So at the end of the robot's useful working life, we have a take-back policy. There are a number of obviously electronic and complicated materials used in the robot construction which cannot be disposed of in standard ground fill. And we have a take-back life policy, and we will dispose of it for free for you. I hope that has given you a brief overview of the Zeus UGV and is suitable for you. And of course, I'm available to take any questions. And I look forward to speaking with you in the future. Thank you.